Continuing with notes for this method, let's look at number 3. So it says find the volume of the solid bounded by the line y equals 1. That's this horizontal line here. The y-axis, here we see the y-axis, and the graph y equals x squared. So here we see clearly our shaded region kind of resembles a little bit of a quarter circle here. And rotate it about the line y equals 1, so that's where I draw my dotted line to indicate that I'm taking this two-dimensional shaded region and I'm rotating it this way, letting this be the center of the object, and we're rotating this way. Okay. Now, first off, we see that there's only one function that's rotated around this line, and we're going to be drawing next, drawing our radius, big R. Okay. Later in washer method, we're going to discover another radius that we have to subtract out. But for now, there's only one radius to worry about. And so that radius, we're going to take our pen or pencil, place it on our dotted line, our axis of revolution, and we're going to extend to the other boundary. Sometimes the boundary is going to be above, sometimes the boundary is going to be below, but either case, we're just going to connect that distance between our axis of revolution and our boundary of our shaded region, and we're going to call that big radius. Okay. So now we have to find an expression that represents that distance, because that distance is going to change depending if we draw it here or if we draw it here. But the consistency is that we're going to always have a top function and the bottom function. And if we put into the formula, then no matter where we draw the radius, we're going to have a formula that will tell us the exact distance. So big radius is going to be top minus bottom. The top of the radius is sitting on the y equals 1. So that goes here. Minus parentheses. The bottom is the y equals x squared. So we place it here. So that's the bottom function, y equals x squared. Now we have top minus bottom, 1 minus x squared. So we also need to include our bounds. So our bounds will go from the left interval to the rightmost endpoint of our shaded region. So the left endpoint that we see, the furthest left has an x value of 0. The furthest right has the x value of 1. So we simply put into our formula pi integral from 0 to 1. Big radius being the 1 minus x squared. So this is going to go in place of r of x, but we have to make sure that we square that entire expression. The reason being we have to have this circle component because we're rotating 360 degrees. So the pi, the big radius, and the squared all have to be part of the formula. Okay? Fill that out with dx. And now the rest we use our calculator, either the TI-84, Math 9 FN integral, or the 36X Pro, which if you do second, go to second, and then E, and that will show the notation that you can fill in for definite integral. Okay. We enter all that in the calculator. Now, when you enter in your calculator, you're going to leave the pi out of your calculator, and then in return, you're going to get a decimal, and that decimal you can always use that fraction conversion button right here to convert that to a fractional value. And then once you get that fractional value, then you're going to add in that pi yourself. So our volume of this, once this rotation is complete, the full volume of this object is going to have a volume of 8/15 pi cubic units. All right, number 4, find the volume of the solid bounded by the line y equals 0. So that's the x-axis. X equals 1, that's the vertical line here. The graph y equals x squared, that's the curve here. And we see clearly our shaded region is this kind of a triangle-shaped object with a little bit of a curve here. rotate it around the x-axis. So that is going to be our dotted line. That's going to be the center. This is the center of the object, and we're going to try to think of this as rotating this way. Okay, so next step, we're going to draw our radius. So we're going to extend from the axis of revolution to the boundary. In this case, we're going to draw up to our boundary. Once we have that representative radius, then we're going to find a formula for, or an expression for this radius. So we do top minus bottom. The top is sitting on the x squared on the curve. Okay, the bottom of the radius is sitting on the 0. So we go top minus bottom, which will be x squared minus 0, which will simplify to just be x squared. And now we just put it into our this method formula. The x squared will take the place of the r of x within our formula. Our bounds will be from 0 to 1. We can simplify this to be x to the 4th, or simply enter this in our calculator. Again, leave the pi out of your calculator. You'll get 0.2, which you can leave it in that decimal form or convert it to a fraction of 1/5, and then you're going to add in that pi yourself. Number 5. Okay, find the volume of the solid bounded by the line x equals 1. Okay, y equals -1. That's this line here. Y-axis, and the graph of y equals x squared. That's this curve here. So if we are to consider these are the boundaries of our shaded region, then we're going to shade in this entire region here. So the x-axis is not going to factor into our region. It's just there as part of the graph, but it's not the full shaded region. The full shaded region is going to be the three straight lines with the curve on top. We're going to rotate this about the line y equals -1. And now we're going to draw our radius. So our radius is going to extend from the axis of revolution all the way to the furthest boundary of our shaded region. Again, the x-axis is not a boundary of our shaded region. We're going to extend all the way to this curve here. Okay, so now the next step, we're going to do top minus bottom. The top of the radius is sitting on the x squared, minus the bottom is sitting on the -1, so x squared minus a -1. We clean this up, the two negatives becomes positive, we get x squared plus 1. So the x squared plus 1 is going to take the place of the r of x within our this method formula, and our bounds will be from 0 to 1. That's the furthest left and furthest right of our shaded region. Now we enter in our calculator. Again, leave the pi out of it. Use your calculator, TI-84 or online calculator or the 36 Pro. We'll get 28 over 15. Add the pi in ourselves. Call it cubic units. Okay, last one here, number 6. Find the volume of the solid bounded by the equation x squared minus x and y equals 6, rotated about the line y equals 6. So here's my curve. Here's my line y equals 6. Here's my axis of revolution, also y equals 6. Here's our shaded region. Again, the shaded region is just the parabola and the line y equals 6. So the x and the y-axis, even though it intersects the shaded region, is not part of the shaded region. So we can just ignore the y-axis, ignore the x-axis. Okay, now something... okay, so let's find the radius here. So we're going to start on the axis of revolution, extend to the boundary of our shaded region. We're going to go down to reach that boundary. Next step, we do top minus bottom. Top is sitting on the line y equals 6. The bottom is sitting on the curve, the x squared minus x. Make sure you protect that parentheses, or protect that bottom function with a set of parentheses. Otherwise, the negative is not going to get distributed. We distribute the negative through. We get 6 minus x squared plus x, and that will go in place of r of x within our this method formula. Now this diagram does not present to us our bounds, so we need to find it ourselves. We're going to have to set the equations equal to each other and find these intersecting x value points. So we take the curve x squared minus x, we take the horizontal line y equals 6, we set them equal to each other. So when we set them equal to each other, we're going to bring everything over to one side, subtract the 6 over. This is a factorable equation expression, so we can multiply it to be -6, adds it to be -1, will be -3 and +2. Solve for x, we get 3 and -2. Those are our bounds, integral bounds. And now we can plug into our formula. R of x gets replaced with 6 minus x squared plus x, lower bound -2, upper bound 3. Enter in our calculator, leave the pi out of the calculator. You'll get a decimal, convert that decimal to a fraction, 625/6, add the pi, and then cubic units.